Good evening, everyone. This webinar is proudly presented by Unique Measurement Service. So, we have successfully completed two webinars, and this is our third webinar. So, thank you all for taking the time to join us today. We are excited to share our valuable industry sites that will enhance our quality and metrology knowledge. So, before we have to follow some steps, welcome to the class. And we will have an introduction about our trainer, and thank you for joining us. So please mute your mics and use chat box for questions. The Unique Measurement Service was established in 2015. Our headquarters is in Chennai. We have 16 plus branches all over in India. So we are one of the largest industrial measurement and calibration service provider in the country. So we operate with highly advanced measuring machines, fully automated CNC measurement machines with high accuracy and reliability. We also provide 24 hours service support across India. In addition, we have successfully trained 10,000 plus engineers and supported their placements to their metrology and quality field. So we have various inspection like CMM inspection and portable for on-site and calibration service we are providing, and also we are doing reverse engineering, 2D and 3D modeling, and also metrology. We are providing metrology trainings. So currently, our vision is vision in 2013 to educate and to train 10,000 plus engineer freshers training program with placement in metrology related field. So this is our vision. And our trainer, today's session trainer, Mr. Naveen. So he have hands-on experience in supplier quality assurance, process quality, and customer quality. He has been worked in top OEM companies, and also he has international exposure across India, Korea, China, and USA. He is passionate about practical learning and regularly shares industry focused knowledge on quality control tools, CMM practices, and dimensional inspection APQP. In such quality topics, we are very honored to have him with us. So
Thank you, Joshua.
yeah, sure. Let's quickly get into the session. So I'm handovering the session to Naveen.
Hi guys, welcome to everyone. Have a good evening. So today we will see the quality tools very widely across industry, automotive, and as well as logistics and machinery industries. So we will see in depth of each tool how it will be useful in daily industries, and it will enhance our skills over in quality across QC. If you are in quality control, if you are in production, if you are in quality assurance as customer quality, it will helpful for everyone. Joshua, my screen is visible.
Yes, visible.
Okay, okay. So today, so what for every problem, for every customer complaint, for every in-house tool, as a quality engineer, we need to use some of the tool. So in today's industry 4.0, we have so many types of tool like PDCA, Ishikawa, Pareto 80 by 20, flowchart, 7QC tools, DMAC. There is so many types of tools. So based upon the problem and based upon the situation and based upon the complaint, we need to select the quality tool. For example, if it is a major project, if it is a minor project, or if it is a minor complaint or a major complaint. So for all issues, as a quality engineer, as a customer quality, as a production engineer, we need to use the tools. So today we are coming for this section, especially for the quality tools. So how these tools has been used in automotive industry as well as manufacturing and wherever the warehouse and logistics type. So what is this quality tools mainly? Without quality tools, improvement is just guessing. As a quality engineer, we need to use the tool, we need to find out the potential causes, and we need to improve quality through continuous improvement. So without using this data, our improvement is just guessing. So it should not, equality is not a guesswork. It has been a stringent plan with action plan, with corrective action and preventive action, with validation. We need to close a issue. So without using any tool, our improvement, our action is just guessing work. So we will go. The quality tools doesn't fix the problem. They reveal the hidden causes so we can solve them right the first time. So if there is any issue in the customer place, if you're taking action through guesswork without using tools, the problem will come again within 30 days or within 60 days or within 90 days. Again, as a quality engineering, we need to work. That's why we need to use tools, quality tools. That's why here the sentence is saying that quality tools does not fix problem. They reveal the hidden causes so we can solve them right the first time. So coming to here the PDCA cycle, this is a very simple tool we can use for the quality issues or quality improvement or quality processes. So it has been plan, do, check, act. Any type of improvement or any type of problem, we need to plan it very well, identify the problem clearly, and understand the root cause using data analysis tool. Set measurements object and create a detailed action plan to achieve improvement. If you want to reduce any ppm, so we need to collect the data for last 6 months in-house data, and we need to measure what component is getting very high issues. It is a painting related or machining related or forming related or assembly related. You need to be plan it very well before starting any improvement or any type of quality analysis. We need to collect the data and plan it accordingly. This planning structure is very crucial in the first step. If you doesn't plan correctly, the do, check, act will spoil. So whenever you do the plan, we must collect the data, at least 6 months data, or else we need to do some brainstorming or benchmark data. We need to take that one, we need to plan. And second step here, the do. Implement the planned solution on a small scale or the pilot batch. Whenever you have planned something and we need to implement that one. For example, you have planned one process before and after. Before the torque was 100 Newton meter. Now the torque was 120 Newton meter. So we need to implement the pilot batch, 100 machines or 50 machines or even 20 machines. We need to be implement that plan and train the people, execute the change and collect performance data during implementation. Whenever you are doing this implementation, the quality improvement engineer, there will be a new product development or quality control or quality assurance will do this activity. They will collect all details, how much torque was 110 Newton meter, how was the performance. Everyone should be aware for the plan. So this is the do activity. Check, compare actual results with the expected target. So whatever we have planned over here, we need to be revalidate with this check. Analysis whether this change reduce the problem and identify any gaps. For example, here we have a loosened torque issue. You have a loosened torque 100 meters, 100 Newton meter. So here you have implemented 110 Newton meter. In check, you need to be check and analysis whether this improvement has been drastically increased or reduced or identify any gaps. So once this process has been done, if successful, the standard solution implemented across all relevant areas. If not successful, refine the plan as repeat the cycle as a plan. If this plan is not achieved, the 110 Newton meter is not okay. Again, the torque is coming loose. Again, we need to go back to plan and need to brainstorm again and benchmark again, and we need to implement and check. So basically, PDCA is a very good improvement tool, as I can say. It will improve your process. It will reduce your defect. So in some companies, they will do proactively before identifying issue at the customer end. They will implement this process before itself, and they will monitor the process, and they will reduce the PPM or defect or DPM, something. In some organization, once the issue has been repeated, they will form a team and they will form a PDCA. So here one example we will see. So in logistics, how can we use on-time delivery improvement in logistics? The problem frequently late deliveries to customer. This is a problem. So here the plan, do, check, act, how it will be changed. Plan, analysis delivery data from the last 3 months. We need to take the last 3 months data. When was the delay? Why it's delay? It is a traffic or planning or loading time, what? Set target. Improve on-time delivery from 82% to 92. So this is your completely plan. As I said here, we need to plan very well. So this is our planning. So once planning is completed, implement routine optimization through software like PLM, QMS, MES, like that. Standardized loading check sheet. The loading check sheet we need to be update, or new check sheet we need to be create, and we need to be monitor. And train drivers on time management. Say time management, some drivers will not aware about the time management. They will not aware about the customer, what time they want material. So these things and all we need to give training, and we need to do some check sheets, and we need to do some update the software. And check, monitor weekly on-time delivery performance. Once we have implemented this, we need to be monitor every week. It is the trend is increasing or decline. We need to check, compare new data versus the previous price trend. Whatever you taken here 3 months data, we need to compare with the previous data. And act, once it has been successfully completed, we need to be standardized successful routine method, update SOP for the dispatch planning, continuous monitor and improve further. So PDCA turns logistic fighter into a structured improvement system. So basically you need to be understand over here, whatever we have planned, we need to approachly next steps we need to do, or else it will not properly implemented at any stage. Without proper planning, we cannot close the PDCA cycle. So this is one of the improvement tool for continuous improvement and the problem reduction. Coming to second tool, Ishikawa diagram. So this is a just format. This has been formed by Ishikawa diagram. They will called as another name like cause and effect diagram. So this is basically, for example, any problem. To identify the potential failures in the man, method, machine, environment, and the material. So this has been formed as a CFT, and they will check in SIXM. As a quality engineer, as a problem, we need to be define the problem, and we need to check whether it has been issue in man, method, or machine, or environment, or what, where it is the issue is happening. Sometimes issue will be observed in each M. For example, issue in manpower and machine and methods and material, and as well as measurement and environment. So this tool is very important to identify the root cause analysis. Potential cause we will identify before taking root cause and before taking any corrective action. This fishbone diagram will helpful to identify the root cause. Potential cause. Once you have identified the potential cause, then you need to be apply the corrective action and as well as preventive action. So this is a format of the fishbone diagram. You need to write over here the each potential causes under the M. Manpower is unaware about the process. Manpower has came late. Manpower didn't follow the SOP. So machine coolant time is low. Machine setting parameter is not followed. Like this, we need to each and every M potential cause we need to be highlighted over here. Coming to second slide, this is a just example of automotive. My problem is high rejection rate due to paint peeling on the car body panels in automotive plant. So we will break down of the potential cause of man, machine, method, material, measurement, and environment. Okay. Here the man, improper surface cleaning by operator. So we need to be highlight this as a man potential cause. And training on the paint process, we need to be highlight on train on the training on the paint process. And coming to machine, in machine, the spray gun pressure variation is there, oven temperature fluctuation. So as a quality engineering, we need to highlight all these cases like material low quality primer, contaminated paint batch, inaccurate thickness, gauge reading, no adduction test is validation. These are all potential cause. Once you are eliminating each potential cause in each M, you will find only one issue has been permanently has been observed. So for example, if you are maintain the contaminated paint batch, so for this you need to take action. So this and all potential cause. Again, many people will confuse Ishikawa is a root cause analysis tool. Yes, it's a root cause analysis tool, but before analyzing the root cause, you need to be identify the potential cause failures in each M, like man, method, machine, environment. So as a quality engineer, we need to be find all these potential causes and you need to put the table. Each one issues should be solved. For example, improper surface cleaning by operator. You need to be trained operator to ensure each shift properly cleaned. And training, we need to give training like 6 months, 3 months, quarterly, or Q1 or Q2. You need to be map this and you need to be give the training. And spray gun pressure variation, we need to check as per the control plan whether the spray gun's pressure variation is okay or not. If it is not okay, we need to raise NCR and we need to follow up with production engineering and manufacturing engineering to solve this issue. And oven temperature fluctuation, why oven temperature is fluctuation? So whether our oven temperature is 180 plus or minus 10 degrees, why it is fluctuating? What is the problem? We need to be highlight and we need to be solve this one. And improper curing time. Curing time, why is improper? As per control plan, 1 hour, but production doing for 45 minutes. As a quality engineering, we need to be highlight this and you need to be get solution from them. And the improper surface preparation process. This and all potential causes, you need to be highlighted to the production engineering or manufacturing engineering, and you need to find the root cause. Once root cause has been identified, you need to take the action and you need to close the issue of high rejection rate due to the paint process. While explaining, this tool might look like a simple, but whenever you are really working on this tool, there is a lot of stuff we need to collect before mapping the Ishikawa diagram. And each and every M, it's very useful, and each and every M we need to be follow and monitor and must be should close that potential cause. In case any one potential cause you find no addition test validation, dust contamination, or only issue was contaminated paint batch. So, and then we need to create this one and we need to map Ishikawa diagram, and we need to take action for contamination. Why contamination? Material issue. Again, we need to give the Ishikawa for this. So, like this, very structured, systematic approach Ishikawa diagram. If you want really to see the results in your plant, you start using Ishikawa, collect data, see the potential failures across the M, and get corrected by them through manufacturing engineering or production engineering. And once it has been solved, apply the root cause analysis like corrective action and preventive action. And finally, validation. So this is the structured process. So this is called Ishikawa diagram, or another name is called as cause and effect diagram. That means cause and effect. In this sentence only, you can easily identify what is the cause of this problem we are identifying in the complete M. Now coming to next SIPOX, it is not root cause analysis tool. It is a process tool. For example, a new employee join in the company. He doesn't know who is supplier, what is input, what is problem, and what is customer, and what is these things. They didn't know. And coming to new product development, they will identify who is supplier, who is input, who is customer, who is output. Basically, this SIPOX tool will easily identify the processes. It will stabilize the process. For example, in automotive plant, I don't know what happening after the car has been road test happened. Road test is completed for the car test. Once road test is completed, what is the process? No one knows. That time they will use the SIPOX diagram. SIPOX diagram is nothing but SIPOX is typically used at the beginning of the project to clearly understand the process before detailed analysis. For example, the SIPOX will use before using the DMAC process. Whenever you are defining phase of the Six Sigma, we will analysis what is the problem, who is the supplier, who is the customer, what is the product, what is the input. In plan phase also, in our plan phase also, we will use the SIPOX. In like DMAC process also, we will use SIPOX. So SIPOX is nothing but, for example, I am using the DMAC process, I am planning. Who provides the input? Who is the supplier? Who is giving the raw material? And what material data or resources are required? Input. Coming to process, what are the major steps? 4 to 7 steps. Operation 10, Operation 20, Operation 30, and on so. And what is the output? What you produce? You are producing washing machine, you are producing a car, you are producing aerospace, or you are producing defense machine. And who is your customer? So this is a basically workflow approach method. Whenever you are using Six Sigma, PDCA, or you are developing a new processes, or you are developing a new machine setup, the SIPOX process will definitely be required. And when the SIPOX is used to clearly define process boundaries, who is supplier, who is input and process and output and customer. And the SIPOX is usually created in the defined phase of the Six Sigma before jumping into root cause analysis. For example, SIPOX, I will give one example. For example, in each industry like automotive manufacturing and any type of company, they have a SIPOX tool. So coming to EMS, as Joshua explained, they are doing calibration and they are doing reverse engineering and they are doing printings and they're doing the calibrations. This and all the service given by UMS. For example, if you're doing the SIPOX for UMS, supplier who? Supplier and service given by who? What is input? What UMS is providing to customer and what processes they're following? If you're giving the instrument for the calibration, what steps they are following? And output, after calibration, how many days they will give the service? And who is the customer? So these all details clearly mentioned by the SIPOX. For example, SIPOX will, for example, UMS will get the material from some another institution, like they are getting calibration instruments, like they are getting some materials from suppliers, and the input and process and output and customer. This is a simple tool to define as a DMAC. In coming sections, we will see the DMAC process. One complete section, we are planning the DMAC only. So in that SIPOX will understand, we will flowchart, we will put the flowcharts and will clearly in-depth SIPOX we will explain to you. And coming to next, SIPOX when to use. So starting a new improvement project, as I told, whenever you are implementing the new project, like example, new car, new engine, or example, or new employee or the process, that time you can use this SIPOX. It will very useful to you. And entering into defined phase, the process scope is unclear. For example, in some companies, the incoming material required testing or not, required inspection or not, this need to be a lot inspection. That time, when we don't have the process is unclear, unconfused, that time you can use the SIPOX. Different departments having different understanding of the same process. For example, as a quality person, you have different processes. As a production person, they have different. As a supply chain, they have different. That time you can use the SIPOX. And you need to identify the stakeholder, supplier and customer. Who is our supplier? Nobody knows our supplier in automotive. In automotive, there is a lot of suppliers in supply chain management, like painting commodity, machining commodity, plastic commodity, and stickers commodity, and coming as tires commodity. There is a multiple suppliers are there. This SIPOX tool will use by supplier quality engineering for commodity wise, like a plastic commodity, who is the supplier, like machining commodity, who is the supplier. So based upon the SIPOX flow chart, we can identify our suppliers and as well as our customers. In automotive OEM company, they have customers like dealership. In Andhra Pradesh, how many dealership you have, like SIPOX tool they can use, customers. And how many in Tamil Nadu, how many in North, how many in Goa, how many in the Bengal, like that we can use a SIPOX tool and we can identify our the customers. Before creating detailed process map or value map streaming. Value map also one of the type of the tool we can use a SIPOX over value map, value stream map, identifying the bottlenecks through value map. There also we can use a SIPOX. When solving cross-functional problems, whenever you are using solving the problems in sourcing and supply chain and production, we can use this SIPOX tool. The team is confused about who, what, and where the process starts and ends. The time use SIPOX first. So this is a basically approach tool to identify who is supplier, who is what is input, what is our product, what is our output, and who is our customer. Okay. And coming to 5i, this is a very great tool for root cause analysis. Who, what, when, where, why, and how. So basically this 5i tool, it's a very brainstorming approach. It's our versus we can ask our why to ourselves, what is happening, why is happening, when is happening, where is happening. So whenever you're using you are asking by yourself, we will get so many of answers. Not only in professional life, in personal life as well as professional life, this will helpful. This tool will helpful. Very, 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 very nice way. Who, what, when, where, and why. This is very, very important tool. So coming to example, this is a simple 5i simple tool. 5i is a simple problem solving tool that uncovers the root cause by repeatedly asking why until the fundamental issue is found. So just one example I'm giving over here, problem, the car engine failed during testing. The car engine failed during testing, for example, road test or validation test or durability test, whatever. As a quality engineer, we need to ask why the engine failed. Due to engine overheat. Why the engine is overheat? Due to coolant level was low. Again, we need to ask why coolant level was low. Coolant leak in radiator. So we need to ask again why radiator hose was cracked. And we need to finally get an answer of our poor quality material used in the hose. So this is the why analysis. We need to ask for each and every problem for in-house or customer or any improvement type of processes. We can ask who, when, where, at what, these things. Once you got the root cause analysis, the host material is problem, then finally we can replace with higher quality material. So this is for applicable for each and every problem. This is looks like easy tool, but it is very difficult tool. We need to ask why until the root cause found. In UMS, if you take one example, calibration, they have done good calibration. There's no need to use any tool. In case they have any problem in the calibration tool, you need to ask why the calibration has been missed, why the calibration has not identified, why the calibration is not functioning, why it is not functioning. Until UMS quality engineer guy to give the root cause analysis as a verification by the customer, you need to validate whether the UMS has been submitted correct YY analysis or not. So as a quality engineer, we need to write a YY analysis as well as we need to validate whether the YY analysis is okay or not. Actually, in industry, what they will do, any corrective action, any preventive action, any type of analysis tool, they will monitor up to 90 days. And after 19th day, they will audit and they will check that problem is whether happening or not. In this case, we have used radiator hose material has been problem. Directly, they will not replace the higher quality material. They will check how many inventory is there. So here the SIPAX will use. Here input, here it will use. How many hose materials are there? What is the inventory cost? How much days we can use this radiator? So they will supplier quality engineer or quality engineer will check all details. Okay, the hose is material leakage. Until to consume this inventory, I want 100% inspection for this hose from supplier. Again, here it will use by SIPOX will use over here. So each and every why we need to clearly define the process. Any action, we cannot able to directly take action. That's why there is called CAPA, corrective action and preventive action. Corrective action, what in this case, until my inventory was completed, there should be person to check this material perfectly okay before coming to line. That is the corrective action. Once this inventory has been completed, they finally put a new material or any process parameters, process optimization the material, it will come in preventive action. And corrective action and preventive action both will close after supplier quality or quality engineering will validate whether they are using the correct material or correct process. They will validate exactly and they will close the issue. So this is one of the main tool. Quality engineering, whenever they identify issue, root cause analysis, they need to be patiently and continuous follow-up with the supplier or in-house team or with services. They need to be monitored and they need to check all these things, inventory, materials, everything through use the SIPAX tool, and they need to apply the preventive action and they need to close the issue. For each problem, for each quality problem, we have many tools. What tool at what time, as a quality engineering, we need to define a right tool to solve the quality problem. That is our main motive. So coming to last tool, this is a flow chart. This is one of the very good tool. I can say the flowchart is a visual diagram that show by step sequence of the process, making it easier to understand and analysis and improve. In any type of industries, if you take automotive industry, there is a car door assembly line, there is a tire assembly line, there is an engine assembly line, there is so many lines in automotive. Coming to logistics, there is so many racks, plastic materials, machining materials, and tire materials, stocks. There is so many things over in logistics as well as automobile as well as service. As a quality engineer, we need to map the processes. Here, quick example, I can say the vehicle inspection process start, vehicle arrives at inspection and check documents. All documents are valid or not. No, reject vehicle, end. Yes, continue. And visual inspection. Any visual damage, take decision whether it is okay or not. Yes, repair needed, end. No, continue. Functional test. Test engine, brakes, light, approve vehicle, end. This is the structured process using at automotive vehicle inspection process at the end of the line. Coming to logistics, we have separate material. The material is coming from supplier. What we need to do? We need to receive the material. If material, we need to check the sample inspection, check, or else no, take decision. And if check, if okay, send it to in logistics rack. If no, send back to supplier. So like this, each and everything we need to process. Again, this flowchart will use for new project, to make control plan, to make PFMEA, to make DFMEA. This flowchart will use very clear. As a quality engineer, we must remember before making any type of core tools like process plan, like control plan, PPAP, process PPAP and design PPAP and APQP, first they will use the basic fundamental tool is a flowchart. This flowchart will done by CFT, including production, quality, and manufacturing engineering and R&D engineering and new product engineering. They will develop the plan. First, what we need to do. As a quality engineering, how it will useful for us once problem came, what we need to do first. We need to take interim action like our 8D approach, and we need to give the communication, and we need to give the awareness, and we need to put the quality alert, and we need to form a team, and we need to take and identify the root cause, and we need to make a corrective action, and we need to identify the preventive, and we need to close the issue. So this is the flow. Like in each and every department and each and every sections, there will be a flow. Coming to EMS, they will give the calibration. They have flow. Getting a material from supplier, putting fixtures, taking data and measuring the things. And once has been completed, validating that machine has been working or not, setting the range and properly delivery to customer. So this flowchart tool will helpful how the process flow in each operations. If you take the control plan, if you take the PPAP, if you take the DFMEA, how it will helpful in flowchart, the control plan at operation 20, what exact process are mapping at OP10. At OP20, what exact process are happening at OP20. So this each processes is very, very important. For whom it is very important, like industrial engineering, like PD engineering, the flowchart is very, 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 very important. Why? Because they are setting the cycle time, they're setting a tag time. So each and every process, they need to be very, very carefully. They will review of each process, including taking screws, putting gun, putting turning time. Every time they will calculate through flowchart, and they will definitely use the software. They will convert as these processes into productive time. So this is the example I have given over here in OEMs. The vehicle arrive at the inspection. They will check. They have check sheet. They will all of the documents are valid. They will check all points. If it is okay, they will take decision. If it is no, reject. And coming to visual inspection, and coming to SR no, and function test engine and braking. So now coming to the case studies. So if you have any related case studies, or if you have any kind of doubts when what to use the tools, I can suggest we can use the 7 quality tools we have not covered in this section. We have planned for all that 7 QC tools in separate sections. So as a quality engineering, we can use the 80/20 rule. In 80/20 rule, we can identify the top 5 failures, and we can take action. And we can use the histogram, and we can use the check sheet, and we can use the Ishikawa also. For example, for the minor problem, we can use the PDCA cycle, and for the major problem, we can use the Ishikawa diagram. And coming to major projects, like there is higher defective ratio is there, we can use the DMAC process, define, measure, analysis, improve, control. That is a Six Sigma approach. We can see in the another sections. So today we have covered the flow chart, and 5i, and we have CPOX we have seen, and we have seen Ishikawa and PDCA. So these are the quality tools completely. So if you have any type of questions, you can ask when to use, where to use these tools. We can discuss over, we have again 15 minutes. We can use this, and welcome your answers, and welcome your questions.
So can you share this PPT?
Yeah, I will share to Joshua. Joshua will share it to you.
Okay.
Okay, guys. Any question you have?
No, we don't have.
Any other questions, guys, from logistics, from assembly, from any type of service company or any type of businesses? So you can drop the comments over here. If you cannot able to ask, you can comment over here. I will reply, or I can tell. How to find out 7QC tools format. So 7QC tool formats means like you're asking just format or when to use, where to use. Pawan, you can type your answer. See, there is no specific format for the tools. You can choose the Ishikawa diagram, and if you take the 80/20 rule, you need to take the data and we need to measure. So that in one Excel, one section, me and Joshua will plan for that 7QC tools. We will tell in that formats and everything, the check sheets and histogram and flowchart, how we can use that. Well, we'll tell. There is no specific format for any tool. There is a format like Fishbone, like histogram. It will show the 80/20. So you need to start using that. Then only you can get more idea about 7QC tools. Can you explain about the supplier quality? Supplier quality. So in supplier quality, what you want, Saruna? In supplier quality, there is many things like supplier selection, supplier scorecard, supplier bottlenecks identification, supplier PPAP verification, supplier DMAC. There is many things in there. In which point of view you required about supplier quality?